Hello everybody! Today I'm going to talk about merge sort. Merge sort is one of the most popular sorting algorithms. It's very effective. Also, it takes n log n time in best and worst case to sort an array. So let's see how it works. For example, I want to sort this array of integers. Step 1. Divide array in halves and continue divide sub-arrays till each sub-array has only one element in it, like that. 3, 2, 4, 1, 7, 5. The array that consists of one element only is considered sorted. All you need to do now is to merge those sub-arrays back in sorted sub-arrays till you get the resulted sorted array. To do that, you need to compare each elements and put it in the right order. For example, 3 and 2, 2 is smaller, 2 goes first, 3 go on the back. Then when you compare 4, you need to compare it with 2 again, 2 goes first, you compare 3 with 4, 3 goes second, and then you put 4. Similar approach, same approach you use on the right part. So let's do it again to get the result array. It could be tricky. So first of all, we compare 1 and 2. 1 is smaller, 1 goes on the first place. We increment the counter on the right part, but on the left part we're still on number 2. We compare number 5 and 2. 2 is smaller, 2 goes next. And now we increment the counter on the left part. Over here we're still on number 5. We compare number 3 with 5. 3 is smaller, 3 goes next. Increment the counter on the left part again. Get number 4, compare with 5, put 4 on its order. Now there is no more element left on the left part, so those elements are bigger, right? We just put them back, 5 and 7, on the result array. There are many approaches to implement a merge sort, and one of the most popular difference between the approaches is use extra space, like a temporary array, to store the result, or do it without any extra memory. The second approach is a bit harder, so in my example I'm going to implement the first one. I'm going to use a temporary sub-array to store the result, and maybe later I'll try to do it without any extra memory. Okay, let's see how it works. Let's write a code for merge sort implementation. I'm gonna implement it using recursive approach. So first of all, I wanna use a helper method. I'll call it helper sort, because I wanna manipulate with indexes, with array first and last indexes, and it's gonna be much easier with a helper sort method, which will has first index, it's gonna be 0, and last index of the array, it's array length -1, just like that. I gonna create this method right here. It's gonna be private, will not return anything, and I call it helper sort with same array int L left index and int R. Okay, I missed a semicolon here. Okay, I don't need to create array. Okay, now it's good. So in my helper sort, I'm gonna sort two subs array. Not actually sort, but divide till each sub-array has only one element. So how to do that? I need to count a middle. We'll use for that an expression L plus R minus L divided by 2. Okay, I'm gonna use this expression to avoid integer overflow. Check out my another video, the binary search video there is an explanation why we are using this exact expression. Okay, and going back to my merge sort, I'm gonna call helper sort on the left part and on the right part. To call it, I'm gonna pass same array, same L index, it's the left part, and the right index is gonna be the half of the array, which is middle. Okay, and I'm gonna call helper sort on the right part and pass same array. Now L is gonna start from a middle. Well, actually not from a middle, but from middle plus 1, because we already cover middle over here. We don't need to add same element on the right subarray. And R will remain the same. And now whenever I'm calling this, I need actually to think about expression whenever to stop. So I should stop when L is bigger or equals R. Okay, and there is one element in the array I want to stop, and in this case I'm gonna just return. Right, so first part done. Now we need to merge our parts. So let's create a merge parts method where I'm gonna pass array, left and right indexes. So I'm gonna write merge parts method, which has array and L and R indexes. Okay. As I said, I'm gonna use a temporary subarray, not subarray, a temporary array to store my sorted indexes, sorted values. So I don't want to create that temporary array over here, because it will create a new array each time I'm gonna call merge parts, which is gonna be called recursively. So what I'm gonna do, I'm gonna just pass this temporary array here, and I will create it all the way up here, right? So it will be created just once. New, and it will be array with the same length. It's okay if I add it to method description here, because eventually it will be more effective. Temp, and I'm gonna just update all those calls. And temp. One left here. So right now I need to think about merging. For example, whenever I merge left part, I'm start from a left index, and then I need to think when I'm gonna stop, when left end index should be. So what I'm gonna do is create my left end index, and again it will be in the middle of the array, right? Because I'm merging left parts, the very end left index is in the middle of the array, which is L plus R minus L divided by 2. Same expression we already seen here before. Now when I'm thinking about right part of array, I know that the end is where R index is, but I should think when R should start, right? I should think about right start index. Is that gonna start right after left end? So it will be left end plus 1. Okay? And one more variable here is the size, which equals R minus L plus 1. That's easy. Now, when I'm talking about temporary array, I need to create an index for that array. So it will be current current index. I need it, so I'll be able to increment. It will start from L2. Okay, and I also need two more indexes for left subarray and right subarray. Those are indexes that I'm gonna increment whenever I'm getting value from that subarray to my temporary array. So those gonna be, let's say, left array index, which is left, which equals to L2, and right array index, it equals to right start, right? Okay, and now I'm gonna do the algorithm itself. So I'm gonna create while loop, and the condition in while loop will be till each subarray on the left and right have element in it. So till L is less or equals left end, right? And till, actually not L, but left R, till left or less or equals, and till right R is less or equals right, because right is the end. Okay, and the easiest part left. If array on a left arm is less or equals array on a right part, right arm, then I wanna add that element to my temporary array. To temp current index equals R left R. If I'm adding element from a left part, from a left subarray, I need to increment left R index. Okay. Else, if a right element is smaller, I wanna add that to temporary array. So temp current index equals array right. And now I need to increment the right array index, which is right array index. Okay, at the end, whenever I'm adding left or right element, I still need to increment a current index of my temporary array, just like that. And we're done here. The only thing left, which I talk about in explanation, what if there are some more elements, for example, in a right part, which are bigger than the last element in the left part. So we want just to copy those elements to our temporary array, right? And similar situation can happen with the left part. It could be indexes on the left or right part left. So what I'm gonna do, I'm gonna actually call a system method which calls array copy, which will copy your indexes. It has a bunch of arguments here. There's a source array, start index in a source array, then your destination array, and start index of a destination, and size. So source array, then destination. Source array are our array. We copy our array. And we're gonna start from the left. So the left array index. The destination is a temporary array, and we're gonna start with the current index whenever we end. And the size of elements gonna be left end minus left array plus 1. Those are number of indexes left. We will do same stuff on a right part. Even if there is no elements on one of those parts, 0 elements will be copied, which is not a big deal. Okay. Right array, temporary array, current index, right minus right array plus 1. And now all elements are in temporary array. All I want to do is to copy temporary array to my initial array in the same way. So I'm gonna copy my temporary array starting from a left index to destination array starting from a left, because left is the beginning, and I'm gonna copy size, which is number of elements left. That's it. Thank you. By the way, I got this solution from a cracking code interview book. It's one of the best explanation I get. Thank you.